Hello, we consider a question from Cambridge International Examinations, that is Cambridge International Advanced Subsidiary Level, and this is paper 2, Mathematics, Pure Mathematics 2. The code is 9709/22, October, November 2017. So the question of interest is question 7. It's a continuation of our consideration of introductory calculus, which basically deals with what I will loosely call differentiation and integration. So the question of interest is this. The equation of a curve is x squared plus 4xy plus 2y squared is equal to 7. Find the equation of the tangent to the curve at the point where x is minus 1 and y is 3. Give your answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. That's 6 marks. Roman 2, show that there is no point on the curve at which the gradient is half. That's 4 marks. And that's all. So we dive to the solution. Well, again, let's consider that particular question. And it's the equation of a curve is given as x squared plus 4xy plus 4xy plus 2y squared is equal to 7. Find the equation of the tangent to the curve at the point negative 1, 3. Give your answer in the form. So at the point negative 1, 3, and we give our answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. So first, we seek to get the derivative of this. So first step is d dx of y, d dx of y, which is d dx of x squared plus 4xy plus 2y squared, like that, plus 2y squared. So first step here, we see that this we can get directly, but this we are not able to. And they are similar to, so what we have here, using, we'll actually differentiate this part. Okay, let me do this. So it is d dx of x squared is 2x. And d dx of 4xy is equal to, now that we get using the product rule, and we'll get 4y plus 4x dy dx. Take your time to differentiate this function here and arrive to this. You do that by you let u to be 4x. If you're using product rule, you let u to be 4x and v to be y. Then you find your du dx. You find your du dx, and you also find your dy dx. If you substitute those, because the product rule simply is d dx of uv will be, say, uv prime plus u prime v. That's what it is, yeah. So in this case, you differentiate, you get the derivative of v. This is the derivative of u. That should lead you here. So take your time and ensure that by applying product rule on this, you get this. Okay, the same here. We now want d dx of 2y squared. This again, we apply the chain rule. And the chain rule simply states that dx of y raised to power n is equal to n y raised to power n minus 1 dy dx. That's the chain rule. This is the chain rule, this is the product rule. So applying chain rule on this, we get 4y dy dx. We apply it by first 2 times 2 is the 4. Then we reduce this power by 1 as seen, y raised to power n minus 1. So it will be 2y. So that 4 times 2y, this is 4. Okay, so we see that we have this times this gives us 4. And then y squared, you reduce the y by power 1. So it just becomes y. Then dy dx, which is this. So we have those, and those. So next thing is now we equate. We are told find the equation of the tangent to the curve at the point. So we then need to equate the derivative to 0. So first we have 2x minus 4y plus 4x dy dx plus 4y dy dx. So this is like saying 2x minus 4y minus 4x dy dx plus 4y, this should be equal to 0, plus 4y dy dx is equal to 0. So I can collect the like terms. And in doing so, what I want to remain with dy dx. So if I have that should be 2x. This was just a moment. There's no minus, it's a plus. It's a plus. We have a plus. It's a plus, yeah. It's a plus. So we have a plus, yeah. We have a plus because what is in between is a plus. So if that's the case, then I collect the like terms. And the like terms will be 4x dy dx plus 4y dy dx is equal to, that is all this part, is equal to negative, because this now crosses. It will be negative of 2x plus y. Negative of 2x plus y. So we seek to find what dy dx is. So I'll factorize dy dx. So I say dy dx in bracket 4x plus 4y is equal to 4x plus 4y is equal to minus 2x plus y, like that. Minus 2x plus y. Minus 2x plus y as such. So what then I will end up with is that it means that now dy dx is minus 2x plus y over 4x plus 4y. That's dy dx. And that being so, then at the point -1, 3, we have x to be -1 and y to be 3. So if we substitute that, then we'll be having minus into 2 times x, which is -1, plus 3, all over -4 plus 12, and that gives me, this is -2 plus 3, that's 1, over minus 4 plus 12. Minus 4 plus 12 is, did I just do the right thing? My substitution, let me see. Looks like there is something amiss somewhere. There is something amiss somewhere. So where did we get 2x plus y? Where did we get 2x plus y? We said this is equal to 2x plus y. Where did this come from? It comes from here. It comes from here. And where did that come from? So here we have 2x plus 4y plus 4x that plus 4y is equal to that. So this is 2x plus 4y plus 4y. It's not y. Plus 4 plus 4y. So here we have 4y. 4y. We have 4y. So if we have 4y here, then we are going to get, this is just this, but this is now 4. This is now 4 times 3. So 4 times 3 is 12. So if I have 12 here, this is minus 2. This now is minus 2 plus 12, which is minus 2 plus 12 will be 10 all over. Now it's 4x plus 4y. 4 times that is minus 4 plus 4 times 3, which is 12. And that gives us 8. That gives us 8. And there was a minus outside, so we give it that. So that gives me now minus 5 over 4. So I see that dy dx at this point is minus 5 over 4. So if that is the case, remember the question didn't just want us to get the dy dx, but we now want to use this dy dx to find the equation of that tangent. So the next step will now be, if I have this, the next step will be yes. Now the next step will be, I have this point, and because this is on the tangent, this point is on the tangent, and this is the gradient of the tangent at that point. So I can use an arbitrary point xy and this point 1, minus 1, and 3 to get the equation of the line by saying dy dx, or what I may call change in y over change in x, will be given by y minus 3 over x plus 1 is equal to minus 5 over 4. This tells me that minus 5 into x plus 1 is equal to 4 into y minus 3. So I have minus 5x minus 5 is equal to 4y minus 12. Yeah. So that means if you rearrange that in the right format as required, you should get that 5x plus 4y minus 7. 5x plus 4y minus 7 is equal to 0. And that's the answer. If you rearrange this, you get that. That's the answer. So the other part required us to show that there's no point on the curve at which the gradient is half. There's no point on the curve at which the gradient is half. Show that there's no point on the curve at which the gradient is half. So how do we go about that? We need to show that there are no points where dy dx. So we're saying first see dy dx is equal to half. But what was that dy dx? Our dy dx, I've rubbed it but it was minus 2x minus 4y all over 4 into x plus y. That was it. That was our dy dx. So we equate this to half, which will be minus 2x minus 4y all over 4 into x plus y is equal to half. If we solve this, if we solve for this, then we'll see that upon simplifying this, which you need to, by saying 4 into x plus y, you cross multiply, is equal to 2 into minus 2x minus 4y. If you do that successfully, you should find that y is minus 2 over 3 of x. Y is minus 2 over 3 of x. And if y is minus 2 over 3 of x, we substitute this here. So we'll have, substitute that there, we'll then have, we'll effectively have, wherever there is x, wherever there is y, now you put minus 2 over 3x. So we say substituting y is equal to minus 2 over 3x into the equation, x squared plus 4xy plus 2y squared is equal to 7. We obtain, if you do that, you will obtain x squared is equal to minus 9. That's what you get. If you substitute this where there's y here, you put this, you'll end up with x squared is equal to minus 9. Then we say, since x squared is equal to minus 9 has no real solutions, there are no points on the curve where the gradient is half. And now that marks the end of the solution. If you followed those procedures, then you should be able to score full marks. Up to there, I urge you to follow me to my next video.